That's been there since 2005.
Yeah. Okay, we're going to get started, I hope. So we need to step aside. I need to point at my sign. Thank you.
Now I'm trapped.
Yeah. So this is, who's here for plug? Good, okay. Are there any new people? Anybody never been here before? Excellent. And what brings you?
I'm trying to check out more kind of tech-related networking events in the area. So
awesome.
Good to see what's done.
Excellent. So this is the Portland Linux Unix group. We have a speaker, which is awesome. However, here on the top of the list here, we need speakers continually. I think I've got 2 lined up for the next few months. Vaguely lined up, like they've said, oh, yeah, I could talk. Contact me in January. So they're not like inked in. Next thing is we're probably not going to have a meeting in January because it's the 1st and the building will be closed, although maybe I could get in, I'm not sure. I think we're just going to scotch January and move straight on to February. But if you've got ideas for speakers, if you want to speak yourself, if you know anybody who might want to speak, get a hold of me because you got a willing speaker acceptor here. We have an excellent speaker tonight. I'm quite confident. It's a super interesting topic anyway. So I'm looking forward to that. Yeah, exactly. I actually know Anthony from the local IRC channel, only I didn't know who he was. And then he showed up at an EFF event that I was at, and we started to chat. And so, yay, excellent. He's here. Yes?
I got one short announcement.
Yes.
Anybody desperately looking for some place to speak, the Linux Fest Northwest
yes.
has their speaker submission form open to the end of the month.
And that's up in Bellingham.
And that's in Bellingham,
Yeah.
Washington in April.
Right.
It's a really fun event. I highly recommend it. And if you don't get it in by the end of the month, it's been my experience that a little bit late, they usually make a room for you.
Yes, we have the plug coordinator emeritus in the room tonight, so that's awesome. We relaunched the clinic as of last spring sometime. We've been holding it at the Willamette University Graduate Center, mumble. In the what used to be the Eco Trust building in Northwest Portland. However, we're not going to be there this month. We're going to be at a large community room at the Albina Branch Library, which we're going to try out for a month and see how that goes. We might, my understanding is that we're welcome back at Willamette, but given the proximity to the holiday on the 21st, we decided to try this out. I also am cultivating connections with the Multnomah County Library, so I want to try this out. So we're going to try Albina Branch Library, December 21st, 1 to 5. I think, who saw the thing on the mailing list I posted about the City of Portland's computer lab? Yeah.
Oh.
So I was stunned a couple months ago to find out that there was this thing called a computer lab at a community center in North Portland. And because I'd never heard of it before, and I'd been saying, hey, you really ought to have a computer lab in various my conjunctions with the city people. And they said, yeah. And then oh my God, there's this thing on their website. So I happened to be up there yesterday, and I walked in, and I say, hey, I'm here to see your computer lab. And they say, oh yeah, we don't have that anymore. It was like defunct as of before the pandemic. So there's a guy on the, Patrick, I believe his name is, on the mailing list, who we know and sometimes comes to meetings. He actually works for the Parks Bureau. So there's some potential that will foster a relationship that might reinvigorate that thing. The cool thing was that it was 25 boxes that Free Geek had put together in 2012, and they're all running Linux. So when given the state of Free Geek, I was curious how that thing was going, and maybe the plug could help them out. And that was what initiated my visit there. And it's nothing to help at the moment. So maybe that'll get reinvigorated, maybe not.
From the thread, was that, they said they got it set up in 2012?
It was initially set up in 2012. The guy I talked to at the community center said there'd been some kind of hardware refresh in 2016.
Oh, okay.
And then,
Okay.
like a few years later, it was dead.
I was going to ask, is 2012, if that's what the era, that would be the operating system they would have been running, would have been the one that I built.
It was
there.
it was described in the press release as Ubuntu. But I mean,
That
yeah,
was right when they switched.
yeah, I don't know.
So yeah, that was that year. But.
And after this meeting, a bunch of us people who are 21 and older sometimes go to this place called Patty's down at First and Yamhill, and anybody's welcome to come along. And if you need a ride, what we used to say? Hang out by the door. Anyway, come find somebody. We can probably get you a ride down there. And with that, we're ready for our speaker. So
I guess I pulled my mic off. Sorry. I'm not even started yet.
and push the button.
Well, I'm going to get this back on first so that we don't record all the...
We're having some audio issues, so no rush.
All right, I'm hitting the button.
It'll turn red.
Awesome. It has turned red.
Full of text.
All right. Yeah, let's see. Yeah, good enough. Can I move this thing so I can see people? It's better. My name is Anthony Sorace. It's really nice to be here. Thank you for having me at the Portland Linux Users Group, where I will talk about something that is neither Linux nor Unix. This is all about Plan 9, which is in the same family, very much. We'll see. So this is sort of my agenda for tonight, but feel free to ask questions at any time, jump in. But what is this thing? Why should we care about it? Maybe I have a little tour of some of the more interesting parts, why you might or might not want to try it, and the sort of current state of the landscape, if that's something you want to check out. Okay, so what is Plan 9? It's a Unix-inspired general-purpose operating system, which is entirely true and a mostly useless definition. It's hard to talk about things that are general-purpose because Plan 9 has been successfully run on gigantic supercomputer clusters put together by IBM. It has been run on little tiny embedded devices. I use it as a workstation operating system. So, general-purpose operating system. It is probably better at the top and bottom end of things. If you want to run it as a workstation system, you can definitely do that. You need to really want to do that. But for the outside of that sort of middle ground, it's great in a lot of interesting ways. It is in the same family because it came from the same place. This was the folks that designed Unix at Bell Labs sort of looked at Unix in the mid to late 80s and said, hey, we did a good job. There are things we could have done better. So with 20 years of extra experience, how did they revisit those ideas and apply them to a more modern world? And modern means like 1989 as opposed to 1969. So, modern is relative. There were a bunch of things that were novel for Unix for the 1969 model that Unix can certainly do, but they feel very bolted on in a lot of ways. And these are newfangled things like networking and graphics. This didn't exist meaningfully in 1969. Networking was very, very minimal. Machines were pretty much freestanding sort of compute appliances that lived in one, institution's basement. You ran it there, and that was that. Graphics existed in various forms, but it was new and exciting. And Unix didn't really have a good answer for how to do it. So those are two of the sort of bigger examples of things that were maybe bolted on afterwards, which is, not to disparage the work that people did to get them there, but they're very clearly outside the model. Let's make that a little bigger. This is from the original Plan 9 paper.
Are we looking at a Plan 9 output on
Sort of, I'm cheating a little bit because I have better fonts installed on my Mac. So this is a Plan 9 program running on my Mac, and I'll talk about how a little bit later. But I am cheating a little bit just to get slightly better fonts. The problem is, well, you can read. You're all smart people. There were big problems that the model of Unix was really well set. And the idea of going in and fixing it would have required too much of a disruption to the model. So they said, great, we're going to keep the ideas, keep the parts that worked, but we're doing something new. This is the most boring slide in the thing. The important parts are 1989 was the first paper. There were a bunch of releases. Around 2010, momentum at Bell Labs really slowed down. AT&T had spun out Lucent, which then got bought by Alcatel, which then got bought by Nokia, and a lot of the people behind it left, largely for Google and some other places, but really largely Google.
So, like early on, what hardware would it have been running on or developed on?
The first, they all ran on PCs. The first two editions ran on a collection of Sun Spark stations, Next terminals, not the cubes, what do they call the slabs, the pizza boxes. It ran on some hardware that they had built themselves. What else did first and second run on? There were some MIPS boxes. And then the third edition was sort of the biggest. The biggest break there was between second and third edition. Some of those platforms got left behind in second edition, and then they added new ones like the Alpha, which was, still kind of relevant in 2000. And, there's a collection of sort of smaller, more esoteric things. So why is it interesting? It's organized around three principles, and the first one, for where we are, everything is a file, right? We all love that mantra. Plan 9 really pushes that one a whole lot farther, and we'll take a look at some of the ways that works out. But really, everything is a file or file tree. You have things that are your audio device, for example, has sort of three files. There's the audio file, which gets data. There's an audio control file where you can, control buffer sizes and things like that. And then there's volume, which is just a convenience shortcut for setting your volume. And the biggest difference between Plan 9's approach to everything as a file and Unix's is that even in Unix, when you have things that are files, we do some very not file-like things to them. Like, what's an IO control? Like, everything else, there's open, close, read, write. Like, we sort of understand what those means at an intuitive level. So Plan 9 does not have IO control because we don't need it. They found better ways to do that using more conventional file operations. So the second point is that 9P is the only way to access files on the system, resources on the system. 9P is a network transparent resource sharing file protocol. You can vaguely think of it as NFS. It is dramatically simpler, but it sort of, at a very high level, fills that role. You have clients and servers that talk to each other, they talk some protocol, and they expose files. And then possibly the biggest difference for people coming from Unix is that processes each get and can manipulate their own namespace, which means things like my audio device might be different from the audio device of another process on the same system. And this is used for all sorts of things, including how we handle like remote login, how you handle running your window manager inside another copy of the window manager. That's virtualized in such a way that the process running and accessing dev audio doesn't know or need to know whether this is a local kernel device on some calling system, or a user mode application presenting the file. All it knows is that it's a 9p server, I'm talking 9p to it, and that's that. And the real power from the system comes in the fact that these principles are applied uniformly throughout the system. That's also why, well, the fact that that isn't true in Unix is sort of the biggest problem with taking some of these ideas and applying them to Unix. There are certainly places where that could be done more, has been done successfully, but that's really the biggest problem with trying to backport some of these ideas. Plan 9 has just the one way to access these resources. Unix provides several for lots of different kinds of resources. But wait, there's more. So that was all sort of about the kernel and the system overall. They were starting from scratch, and they were in a research lab, so they didn't have product pressures on them. They were able to say, we're going to start from scratch. We're going to keep the parts we like, but we're going to ignore things that didn't work out so well or that have sort of accreted over time. And some of these are bigger differences than others. Cat, you all heard the Cat V considered harmful. It was a sort of famous Unix paper that talked about the accretion of options to cat, something that is supposed to just be about concatenating files, and how it was the example of the violation of the sort of do one thing well principle from Unix. Plan 9's cat has no options, just as an example. Lots of things that we're familiar with get reworked like that. Lots of them get the same idea, get sort of a new implementation. So for example, we're all familiar with make. Plan 9 uses muck, which is, it looks like if you look at a make file and squint a bit, it looks like a muck file. Cleans up the syntax, makes doing recursive builds easier. SH is replaced by RC as the shell. Again, just sort of a second take at the idea. Well, in the case of the shell, like a ninth take or something at the idea. Has lists built in as basic types, which makes things so much nicer. That's like the biggest improvement. Lots of other things get cleaned up. And some things get new tools for the same functions, like Ubis is the name of the mail server. It is kind of neat on its own, but the big novel thing about it is it represents your mailbox as virtual file system, so you can like CD into your mailbox and cat message, whatever, 37/header to read just the headers out of it. And Acme is the text editor sort of IDE thing. We'll look at that one later. So it's had some nice outcomes. I said it's hard to take some of these ideas and apply them directly to Unix, but there's been some really good outcomes. Probably the most significant is that UTF-8 was originally developed for and implemented on Plan 9. And now, it's like, that's how we do text. They had almost released the first edition of Plan 9 and using an earlier version of the Xopen group's Unicode encoding, and they didn't really like it. And they got a call from Rob Pike got a call from somebody with the Xopen group saying, hey, we're doing a new one. We'd like you and Ken Thompson to take a look at it and let us know what you think. And they looked at it and they said, well, it's better, but it's still not good. can we give you something better? And the guy from the X-Open folks said, like, well, if you can do it quickly. So they went to a diner, and Ken designed UTF-8 on a placemat, and then they went back to the office, and by the end of the week, they had converted the whole system to use UTF-8. It really, UTF-8 is wonderful on its own, but I think it's a really powerful example of why having this system that you can solve things in the right place, understand the whole system, and you don't have to worry about, so much historical baggage is a really powerful thing. The proc file system go ahead.
Did they call their Unicode library UTF-9?
No. They didn't actually, I don't think they came up with the name UTF-8 either. I think that was sort of retroactively applied to it. But no, they did not. They should have. The 8 is, it's 8 bits, whatever. But yeah, that would have been more amusing. So anyway, /proc on lots of Unixes is directly inspired by Plan 9's /proc for representing processes. If you look at the ones on Unixes, there's a lot of other stuff sort of pushed in there because Unix only really allows for /proc as the way to provide these synthetic files. So they kind of say like, ooh, that's a good idea. We're going to put as much stuff in there as we can. Plan 9 gets to do that for the whole system. So it's a nice advantage.
There's SysFS too.
Yeah. I mean, the idea has shown up in other places, but rfork and clone, the Unix system calls, were both directly inspired by Plan 9's fork, which is much lighter weight than Unix's fork, which I'll come back to that later. Namespaces, the fact that you can modify your namespaces. Linux has picked this up later. That feature in Linux sort of was very unused for a long time. And then Docker is probably the biggest example of a modern use of that on Linux, where it's great. And that came directly from Plan 9. And then sort of honorable mention, these aren't directly Plan 9 ideas, but Porter-Duff compositing is sort of the basis for modern image compositing algebra. Porter and Duff had done that a couple years before Plan 9, but then Tom Duff came to Bell Labs, and Plan 9 was the first sort of system-wide implementation of that idea. And Tom Duff also wrote the RC shell. And CSP was Tony Hoare's idea for how processes could communicating sequential processes, I think that's right. And it's channel-based communication between independent processes. It's used for concurrency. It's the model that's used by Go today, and I think Haskell uses it, and then there's libraries to do it in things like Python and Java and whatever. But it's sort of, again, an older idea. Plan 9 was the first time it got sort of a system-wide application. Okay. Yeah, I have talked a lot without showing you anything. I would like to show you things. This is Plan 9 running in QEMU. My mouse has stopped working. Sorry, technical difficulties. Oh, it jumped, and then I unplugged it. Sorry?
Does anyone here work in tech support or IT?
There it goes.
It works on the, that's frustrating. That's going to be a pain.
Grab thing? It's got like a mouse grabbing thing that sometimes gets confused.
No, it's not, because it's working with the trackpad, but I don't know. I'm going to fiddle with it while I talk. Plan 9 is a text-oriented operating system that is also inherently graphical. This is a graphic program, but you'll notice that everything is text. Plan 9 mostly uses graphics to do text better, but it really is a text-oriented system. The graphics do have, oh, there we go. The graphic system, the graphics applications, the window manager, Acme, the text editor / IDE thing, really want you to have a 3-button mouse, which is why I wanted this to work instead of just the touchpad. So this is Acme. And it's a text editor. And you can vaguely think of it as a text editor the way Emacs is a text editor, where it can be your entire operating system, basically. You can run your mail client and whatever inside of it. Acme is sort of the same way in that regard. Acme implements this differently by providing probably guessed it, a virtual file system to represent all the different windows and access the text on it. Can anyone read that? Is that, yeah.
Did you just like draw a console window?
I did. So this is that's the other window manager. The default window manager on Plan 9 is called Rio. This is actually my own modifications to it called Nile. Get it? It's a particular, Rio's a river, Nile, I'm very clever. So /serv, SRV, represents a bunch of things that are sort of the file descriptors that in almost all of these cases are the file, you can post whatever file descriptor in serve you want. Most of these are the server end of a 9P connection. So I'm going to mount serve nile.a.138 onto whatever. What? Oh, right, I need to, let's try this one. Oh, it did not do what I want. Yeah, it is. All right, well, yeah, it's better to do it in here. Let's take a look at dev. So this is /dev. A lot of this probably looks like, vaguely familiar, sort of an alternate reality version of what you'd see in /dev on a Unix system. And some of these are device files that operate more or less the same as you'd see in a Unix kernel. Many of these are provided by kernel device drivers, but many of them are not. So let's see. WinName is provided by my Windows system. A user mode application provides this file for other applications that want to be able to find windows or change what the window name is, whatever. It's provided virtually by the application that I'm running inside of. And
Are there two copies of it there? Is it the same file twice, or is there a hidden?
It's because of how /dev is put together. So /dev is a union mount. So a bunch of things are mounted onto /dev. So let me see. Let's see. Lib namespace is the file that's run at startup that sort of puts things where you expect them to be. You can see this #s. The hash # is a sort of shortcut for the kernel device drivers. So #s is the thing that provides /serve. It's the kernel device that is mounted onto /serve to get you those things that we were looking at before. We have a whole bunch of kernel devices. #c is your console, your devcons, things like that. What else goes on to dev? Let's see. #s is your storage system, your /dev/sd, whatever, SD00 for your SCSI drive, stuff like that. So all these things are mounted onto /dev, and depending on how you're looking at them, you sometimes get these duplicates because more than one thing that is mounted onto it had dev WinName in it. Does that make sense?
Yeah.
How does it resolve which one you open?
There's an order to them. You can bind when you do a bind, you can either replace what was there before or you can bind the new thing before or after the thing that's already there. So if I...
So there's only really one of them, even though there's two in the thing?
Right, yes. Here. Well, I don't want to figure out what's... User mode file system gives me a new empty /temp. Echo woof into dog. Echo meow into cat. Cat dog. Bind dog cat. Cat cat. Now the cat says woof. And you can do, yeah. Oh, we got the alligator in there too. Yeah, it's great. So you can do this with directories, single files, and the directories is where you start to see those sort of duplicated names, because it's looking at the directories in the order they were bound to and performing a union of the elements in them. But when you go to resolve the name, it resolves to the first one in the stack, whatever is most before in the stack. All right. Let's close that. This might be interesting later. Okay, Acme. So the tour is mostly going to happen in Acme, so I just want to talk about it for a second. I really like Acme as an editor, and as an aside, if you get nothing else out of it, maybe give Acme a shot, and you can do that on Unix. Talk about how later. It really wants you to have a 3-button mouse. That's true. All text is searchable, or selectable and editable. You really want a 3-button mouse because the left mouse button is for selecting text, the right mouse button is for selecting text, and the middle mouse button is for selecting text. It makes more sense. So the left mouse button is like normal selecting text, what we all think of as selecting text. And the middle mouse button is selecting text to execute it. So, date. Going to date, and it gives me the date.
Oh.
And then the right mouse button is for selecting text to search. That's just me clicking on it. And it'll do automatic expansion if you're clicking on something that's a word. Anyway, and mouse courting is, I've tried lots of editors. Mouse courting is the feature that keeps me coming back to Acme. It is a little hard to demo because you can't see what I'm doing with my mouse. But if you select text with button 1, and while you're holding it down, you tap button 2, it cuts it. And if you tap and puts it on your copy buffer. And if you tap button 3, it pastes it. And you can do that over and over again, whatever. There's other chords too for composing text or composing commands in interesting ways, but you get the idea. Really wants you to have a 3-button mouse, but rewards you for having a 3-button mouse with some stuff that once you get the muscle memory down, I find it really hard to use editors that don't do this now.
We have foot pedals and breath switch. Foot pedals and breath switch, that gives you 64 combinations.
Yeah, there's people have played with what to do with like those mice that have like 15 buttons on them for gaming and stuff, and like I don't know, three's fine.
My modern mouse that I have has 6 buttons on it.
Yeah.
It's mouse button 1, 3, 4, 5, and 6, and 7. It skips 2.
Okay.
Because that would be the middle button.
Right.
And so
It doesn't have a middle click?
It doesn't have a middle click. and,
Well-
and clicking on the mouse wheel gives you 8.
So it does have a click.
It clicks, but it's not mapped to number 2.
It's not the one you
Nothing
want.
maps to number 2.
Well, don't use that one.
I have some 3-button mice in my garage that I don't use anymore.
Yeah, excellent.
I have to contact the
Pull them
engineer
out.
on
Pull them
that.
All right, so that's the very brief about Acme. So let's do some Plan 9 stuff.
Before we leave Acme,
yeah.
I have to ask, what is snarf? I've been staring at snarf for 5 minutes.
That is an excellent question. Snarf just means copy. Copy and paste, believe it or not, were terms that somebody had to invent, and they were not ubiquitous in 1989. Just as a user interface operation, they existed. Larry Tesler is the guy that invented them, and his work did predate this by a little bit, but those terms just hadn't become ubiquitous by 1989, so they made up their own, well, I mean, they didn't make up the word, but they sort of made up their own terminology for it, and just never went back and changed it when everybody else calls it copy. It's just copy.
Fascinating.
Okay. Thundercats.
Had they not looked at, like, paper?
Horizontal or vertical
Whoops, snarfing the paper.
See, here's the problem. Remember, Xerox made copy machines and was involved with Unix, and they didn't want to get anywhere close.
Yeah, so
Starting my
Plan
Snarf
9
corporation.
So Plan 9 has or not Plan 9, sorry, Acme has a function where, this is just a text window. I can like make edits. What did I just do to my keyboard? I don't know what I just did. Hold please. What did I do?
You snarfed it.
This weird character. DC3.
Isn't that a control character?
Voice control 3. You don't have to
DC3 is like one of the very ancient ASCII mnemonics for one of the control characters.
Voice
It
control
was like
3.
DC 1, 0, 1, 2, and 3, right?
1, 2, 3, and 4.
Maybe.
So
Okay.
let's try that one.
Yeah.
Snarf sounds more like a cut operation.
I mean, it's weird. It's, I'm not going to particularly defend it as a word. Your options are
And what was with
cut,
the,
paste, or snarf.
the Xerox thing with the Z?
Yeah, so there's they didn't want to get sued, I think.
Yeah.
Let's get rid of this column so we can read things a little better. Where was I? We talked about Acme. So the namespace. So hello. You can make a copy. You can have multiple buffers for the same file, and it keeps them in sync as you're editing. It's nice for code where you have like your defines up here and whatever. And it's called Xerox with a Z because that was didn't want to get sued. Yes, I don't want to actually say those edits.
Sniff, snarf, snarf.
Just think of it as it's a variant way of spelling copy. It's good enough. You can. We can't see those. Never mind. Here. You can run shell windows in Acme. Dev snarf is your copy buffer. I'm going to do this up here. Well, I'll do it in a different window. We'll copy the word look. And, it's just a file.
Oh, so that's your clipboard.
Yeah. There is no distinction between the X11, I don't know,
The
3
selection.
different, yeah. I have never in my life gotten that right on X11 the first time I tried. I don't understand what they were thinking. There's dev snarf is a file. It's your copy buffer, your clipboard.
The clipboards hadn't been invented yet either.
Well, I mean, clipboards have, but
Hadn't been re-implemented yet.
yeah. Anyway, okay, so let's look at some stuff in here. So /n is just a directory that has some file names in it. It is conventionally, these are just directories. These are just plain directories. They're all empty right now. It's just the conventional spot where you mount remote systems. So I'm going to open a window. Here, let's do it in here. Actually, it'll be a little easier to see. And before LF is just my alias. For it's not. They didn't change that one too. 9FS is a shell script that connects to a remote server over the network, makes that 9P connection, posts it in /serve, and then mounts it onto the place I'm telling it to mount it on. So now, that's my server. And like, okay, NFS can do that. That's easy. But let's look at N again. And there's no... I just did LF on /n/9serve, which isn't there. There's a program running called mountgen, MNTGEN, which is bound, the program itself is a 9P server, which gets bound over /n, which synthesizes the directories you need on command, on demand. So you don't have to enumerate every host you would possibly want to talk to. I remember being frustrated with, like, I have, on Unix, I have something bound onto /mount, and then I want to bind something else, but I only have the one /mount, and then unmount it and put something else. We don't have to do that. This works across platforms. So Greenhouse is a FreeBSD server. Did I set this up right? Yes, good. 9FS, since it's just a shell script, can have aliases for doing things. I don't have to be as explicit with the host name and where to put it. And that's my FreeBSD server's root directory. So again, that's cool. NFS can work across platforms too. There's no administrative, there's no common administrative domain between this QEMU, my server somewhere, my Plan 9 server, and my FreeBSD server. So with NFS, you have to really care that your user IDs match, the numeric user IDs match. In this, they're all strings, and it's done at the point of authentication. So these are authenticated mounts, and my user ID, I shouldn't touch the mic, sorry. My user ID is sufficient, and there are no, Plan 9 doesn't have numeric IDs, 9P does not have numeric IDs, and the 9P server on the FreeBSD box is in charge of translating those from the numeric ID, from the string to the numeric ID on the Unix side of things. I'm going to leave that one around because I think I might want to come back to it. Okay. Oh, yeah, so let's look at proc. We talked about proc being one of the things that was brought in to Unix, various Unixes. So this is Plan 9/proc. It's, with the exception of trace, it's all just process IDs. We're going to do, I'm just going to have something sleep for a really long time. And so that I can poke at it. And now there's a different set of processes, except I can't look quickly enough to see which one showed up. So let's see, 1315, great. So we're gonna look in proc/1315, and we get a bunch of files that represent different aspects of looking at this process. So args is the arguments that were used when the thing was run. You could do, if you try to read from wait, it'll wait until the process exits or you get a signal on it, or a note on it. There's different aspects of this process are represented by different things here. Text is the actual binary that was run. because it's the text segment of the process, just in raw form. Now, the debugger uses, what was that, 1315? Okay, so the debugger is called ACID. It's neat. It is a little complicated. It's a really cool programmable debugger, so you can do very complex things with it. It's one of those things where 90-something% of my use of it is I just want to stack trace for my debugger. So let's do that. So that's my stack trace for sleep, which is not a very interesting stack trace, but you get the idea. More interesting things would not fit on the screen. And again, this debugger is just working by reading and writing those files in /proc, which gives us kind of a cool property. Since everything in proc is just files, and the debugger works on reading and writing those files, and 9p is used for all file access, and we can not modify our namespace, we get remote debugging for free. I can just import my servers /proc, and now my debugger is looking at that. So, and serve proc. What did I do? Did I quit something? I don't know what I did. Oh, it's because I'm mounting the file system, not the server. Let's see, import, here, let's, PS, import, so I'm going to open a connection to my CPU server while we're waiting for PS to populate.
And WC, is that word count or something else?
Yeah, yeah.
So did you merge the contents of your server's proc directory into your local one?
Yes.
And now you're listing processes on both machines?
No, this is, import will by default just replace.
Okay.
So I just replaced it with the other one.
The local system's happy with that?
Yes, because it's only in this process. It's only in this shell process.
Oh.
Because
So-
this process has its own
Namespace.
Exactly, exactly.
Now it's starting to make sense, okay.
So I'm going to do a sleep over there.
Everything's a container.
Oh, wait, hold on. Sleep. PS scrap
So
sleep.
you're switching to Plan 9 then, okay.
Yeah, that makes system debugging hard, if everything is containerized.
You do have to pay more attention to what your namespace is. It is definitely a new thing to keep in mind when debugging. But it makes all sorts of other debugging way easier. So if you have like, you know, I was trying really hard to get this done before I got here and I ran out of time. But if you have like a little embedded thing, this is just a Raspberry Pi, but you can run it on smaller stuff too. And you know, it just has a network connection. You can import its /proc and debug it remotely. And also, since they're all just text representations of things, it's architecture independent. So you can debug your ARM or your MIPS system from your nice AMD 64 workstation, and the debugger doesn't do anything special to make that happen. The network protocol isn't doing anything special to make that happen. All right, so I don't know if you can read it. I did a sleep, you know, some large number again. And now if I just tell the debugger, oops, well, that's not going to work. Now I am debugging it on my server, often some cloud, I think it's a Vultr server. And my debugger doesn't know anything different. And I can do all the same stuff. I can stop processes and set breakpoints and whatever. Oops, sorry. Yeah. Anyway, so because we've applied these principles of everything is a file, 9p is the only way to access things, and processes can modify their own namespaces, there's nothing about that that's about debugging, right? But debugging, remote debugging cross-architecture just falls out of it.
Everything is emergent behavior.
Sure. Yeah.
Until you do disassembly of the code.
Yeah, and then like it can tell, it can look at that /proc/whatever/text is the text segment. So it can look at that and say like, oh, this is a 386 executable. This is a, MIPS64 executable, whatever. It still has access to that information, but the representation of it is defined in a way that's not platform dependent. So all of Plan 9's main file systems, and in this instance, I mean file systems in terms of like the things you actually put your normal files on, have had automatic snapshots since the first release. Let me show. Yeah, let me clean up a little bit. So Tahoma is another server that has a lot more storage, so I have the automatic snapshots turned on. This is just the normal root file system for that server. And then I said 9fs is a shell script that puts these file descriptors in serve. So this is the end of this is my end, my client's end of a 9p connection to the server running on Tahoma. I can do a mount with a different argument at the end. And now I get all my dumps since I turned the server on. Doing this.
How do dumps get triggered?
They're scheduled. They're just
Okay.
automatic.
Yeah.
You say this is going to happen every day at 4 a.m.
Perfect.
Whatever. And this is really nice when you combine it with the ability to modify your namespace. So let's say you're debugging something and you're like, did this come from a change in, it worked a month ago. Did this come from a change in the compiler or the library or my code or something else, some data file? You can bind in, if I, let's say I want to see if the compiler is at fault. I can bind 36 bin 8c is the name of our compiler. Onto bin 8c. And now any compilers I do use that compiler from 2023. You can do the same thing with libraries or whatever else you want. It makes debugging things at a system level really nice. Git can do this, of course, with, Git's really great for bisecting changes in a particular tree, but being able to do this at a system-wide level is pretty cool, pretty helpful. Okay.
How do you revert back to where you just were?
Where I just was in what sense?
You just bound your AC in there.
Uh-huh.
Unbind it. Get that out of
Oh, yeah, that's fine. Unmounts.
I don't remember it.
But again, it wouldn't matter, because if I close the shell, then that namespace goes away. But yes, you can absolutely unmount things as well. It's a little, your normal namespace operations are bind, mount, and unmount, which also undoes bind, whatever.
They even have a budget for the letter N.
Yeah. And the create system call has the E at the end. It's amazing.
It doesn't in
Yeah.
Unix?
Yeah. No, it's create.
It's create.
Oh.
All right, so there's been a bunch of file systems in Plan 9 over time. The original one was Ken Thompson wrote something. It was sort of a derivative of the very first Plan 9 kernel that ran no user mode code. It was a dedicated system that ran the file server, and that was it. You talked to it over the network, and that was it. And it managed your dumps. At Bell Labs, it was typically connected to a giant refrigerator-sized optical jukebox, which would have like unimaginably large storage, like 300 gigabytes. In 1996, it was a big deal. And you'd turn the thing on, and it would go through and make sure all the disks were in place. So the little robotic arm would go boom, 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 boom. It was quite something. Now we don't do that anymore. Now we have Venti is the sort of block storage behind Fossil, which is the normal file system. And you can run each without the other, but they're sort of designed to pair together. Venti is one of the first content addressable storage systems. That idea has shown up later in Git and IPFS and a handful of other places. It's basically, the basic idea is I throw my data at this system and it gives me back a SHA hash and says, here's how you get your data back when you want it. And then when I want it, I say, here's my hash, give me my data. And yeah, it's mostly for Fossil, but you can put whatever you want on it. So I use it for my Fossil file system, but also VACFS is a command that will talk to Venti and provide a file system of whatever other data you're throwing at it. So I use this to do backups for a client that I work with, and I have a nice example up here. Why don't I use the nice example? So VACFS wants a score, which is a hash, and the -h tells it the server to talk to. And so that's the backup of my the test version of. I didn't give you the hash for the production version. That's the test version of one of my clients' applications, and it just does that. That's running on FreeBSD, and I just tell it once a day. I think it does it more than once a day. Whatever, it doesn't matter. Once a day or so, it throws all the data at this Venti server. Venti gives it back a hash that represents the entire file tree, and I have a little script that stores that hash somewhere. Notably, the Venti protocol is this thing for give me data, I'm going to give you back a hash. And it has some niceties in it for doing like trees instead of just a block of data. It can understand trees and things like that. That protocol is not 9P. So to talk to it, VACFS talks that protocol out one side of its mouth and 9P out the other so that it can interface with the rest of the system. You can apply that same idea to, we have people have done it with like, I'm blanking on the WebDAV. People have written like a WebDAV server that talks WebDAV out one side of its mouth and 9P out the other. That's how you access those things in a Plan 9 world. Okay. CPU is like SSH, except better. We also have regular SSH because CPU doesn't run on Unix hosts with an asterisk, but mostly.
What's the acronym there?
Which acronym?
What is CPU?
Oh, it's connecting to a CPU server. So typically a Plan 9 network, Plan 9 installation will have an authentication server, a file server, one or more CPU servers, typically a small number, and your terminals. And in the old days, those were like 4 or more separate machines. And today, it's typically 1 or 2, because we don't run a separate file server anymore, stuff like that. So it's just CPU is the command to connect to a CPU server.
That makes sense.
And the way CPU works is a really interesting application of this principle. NS is a command that will, I'll just show you NS. NS will just print out all the commands that were used to construct your namespace.
Oh, wow.
So, it starts from the beginning. I start with root, and I'm binding up my /dev. But for our purpose here, we care about these ones. So mount term, when I do this CPU connection, the shell running on my CPU server gets an IP connection back to my terminal. And then it binds my devcons on top of devcons. It binds my devcons cuddle, which is how you turn on like raw mode, on top of devcons cuddle. And it uses, and then runs the shell. So the login part essentially does the binds and then invokes the shell. So all the commands that I run don't have to know any of this. They just read and write devcons like normal. Same thing for the Windows system. If I can't run the normal Windows system inside Acme because Acme is very text oriented. So if I run, this is, if you can't read it, CPU-H 9serve.net, it's just a CPU connection to my actual server. And then Rio is the default Windows system. And now this Rio is running on my CPU server using my local graphics device. It doesn't know that. It's just the graphics device is bound over where the graphics device would normally be. So Rio works on Windows the same way it normally does. That's done in libprofile. That's not actually super interesting, and I'm taking longer than I expected to. So, I said most of this. A really cool example is, it also means you get /net. Do I have a CPU open? Here, I can do it here. No, you can't see that one. Oh yeah, this is not good. So net is your network stack, your Ethernet device and your IP stack, basically. So mount term net is the IP stack on my my QEMU IP stack here. So now, any process I run on this, like if I run ping on this, the process is running on my CPU server off on a public cloud server, but it's going to use the IP stack on my QEMU instance. So, if someone wants to fire up Netcat, I can send you, if you're on the public, whatever network I'm on, whatever, I could send you data from my CPU server, even though we're all behind what I presume is a natted network that doesn't have real ingress. It's a really neat way to punch through firewalls if you have cooperating systems on both ends. I have a little script called postroot that just makes the CPU connection and posts my root file system into /serve on my CPU server. I forgot to run it before I left home, so I run this at home, and I can get at my entire home network from anywhere else that I happen to be by importing its /net. No such page because that's the end of the tour.
Question,
yeah.
Question, what's the slide?
Slide is just a little script. Oops.
Slide plus minus. Yeah.
Oh, because is that your actual presentation thing, right?
Yes.
Acme.
Yeah, it's just a little script that works by this /mount/acme/winid. All it's doing is reading and writing the file system that Acme presents. So to advance to the next slide, because I tried to execute it up there, which is not what I want.
I And you just have like a set directory with some named files that it switches through?
Exactly, exactly.
Huh.
These are all just plain files. Index is the only one that's special. It just gives the little, this is the order that the things go in, and that the slides go in. These slides correspond to file names that have the content. And it's just plain text. Yeah?
So there's all this transparent network activity going on. Is there a secure layer, encrypted, encrypted
Yeah,
encryption layer?
it runs, it runs SSL or TLS. Yeah.
And I assume there's auth to go with that?
Yes.
How does the auth work? Because it was all silent when you were doing it. Is that?
Yes, there's so much I would like to show you.
Hey, a few more stuff. Go get through that first.
Well, no, I'll just show you the quick version. So there's an auth agent that is vaguely analogous to SSH agent called Factotum, which unsurprisingly at this point, hopefully, presents itself as a file system. So all of these files are synthetic files provided by the user mode application called Factotum, and I can, it stores your passwords, basically. Sort of at runtime, there's a separate thing called secstore, secure store. It's an awkward thing to say. That does sort of encrypted storage of them long-term in a more secure way. And Factotum is sort of the runtime agent that both stores the passwords, but also it's where all of the authentication protocols are implemented. So my CPU command doesn't have to know how to talk the authentication protocol. It just hands a file descriptor to Factotum, says, please do auth for me. And Factotum does so and then lets it know when it's done. If I look at the control file, if I read the control file, it gives you, it says password blank. It knows enough to sort of hide the secretive things. If you to store a password, you write something of this format, except this would look like not really my password. You would write this into the file, and it would add it to the list of things it's storing, and then it shows it with a question mark to when you read it. But if you ask Factotum to do the authentication for you, it has that information and can perform that.
Before you leave the demo thing.
Yeah.
How does network stuff work? Like, how do you know what your IP address is, that sort of thing?
So there's IP self-tab, gives you all the things that count as local. So you see, there's broadcast addresses and whatever.
Nice.
IP route gives you your IP routing stuff. Ether0 is your Ethernet interface, and there's adder tells you the address for that.
That's definitely a real address.
Well, that's the real address as far as
That's key.
TME is concerned. Yeah.
The decimal encoding of the hex of the MAC address?
Yeah.
Oh, wow.
I think this is actually a hex encoding of it. There just don't happen to be any hex digits.
Oh, yeah.
Oh, okay.
I count the right number of digits.
Yeah. Just randomly for what it happened to be. Anyway, and you can, NetTCP gives you all your TCP connections, and you can say, what's the remote side of this particular TCP connection? Gives you this bang syntax is IP address to the left and port number to the right. And if you want to send data on this, you read and write the data file, and that's how you do network connections. And the TCP stack, the device that implements the TCP stack, is smart enough to say, if somebody already has this open, I'm not going to let you open it and spew more data at it. It says that's an open error.
Cool. Thank you.
Yeah. Okay. So why you might want to try it? You might not. It is not for everyone, and it probably doesn't have most of the programs you want. We don't have Emacs. We have VI, but our VI is a MIPS instruction simulator, because there's also like 8i for a 3 to 6 instruction simulator. So we don't have that. We don't. There's a third-party sort of semi-okay-ish port of X11, but there's not really X11. And the big killer for why I said you have to really want to use this if you want to use it as a workstation is it doesn't have a web browser. Which is sometimes great. It actually does have a web. There's multiple web browsers that run on it, but they're all like would have been kind of acceptable-ish in 1996, and aren't anymore. Did I saw a hand?
Can I run Doom?
It can run Doom. I don't have it installed, but it can run Doom.
Can it do Doom multiplayer over 9p?
Not over 9p. I have no idea if I have no idea.
Yeah.
It won't do it over 9p because they didn't modify the Doom code to put that into it.
I'm sure somebody.
I mean, I guess technically it's doing it over 9p because if it's talking to the network, then it's doing 9p. It just doesn't know it.
Is there an IRC client?
Yes, there are multiple. There's NetNews. There's all sorts of stuff from Party Like it's 1999.
Yeah.
I heard something over here. Was
No, I just said it's living in the 90s.
Yeah, I mean, in a lot of ways it is. Things like Factotum are more recent than that.
Will my hair turn back to brown?
I make no promises, but give it a shot.
And what can it run that is not pre-2005?
What can it run that is not pre-2005? I don't.
Can it, or if it can?
Yeah, I mean, there's lots of things that have been written for it since then, but it's like there's like various languages that have been ported to it and run on it. It doesn't have most of them. Like everything here is written in C, straight C, a sort of not quite POSIX dialect of C. There is a POSIX environment. It's so-so. It was originally written for people who wanted to use Plan 9, but occasionally needed to export things to Unix systems. And it's really good for that. It's a lot less good for importing things, although some stuff works. That's how the X11 port was done, for example. And that's how our PostScript interpreter is done. Those are probably the biggest things. But it has Go, it has Lua, it has, I don't know, there's a bunch of languages for it that are kind of newer than that.
Go is interesting.
Well, yeah, so Go was written by a bunch of Plan 9 people who then went off to Google.
Oh, that explains a lot.
Yeah.
That explains
Yeah.
a lot.
So there were steps in between. After Plan 9, they worked on something called Inferno, which is basically take all these ideas and stick it on top of a virtual machine, vaguely similar to the Java virtual machine, stack-oriented rather than, or register-oriented rather than stack-oriented, and like there's other differences, but like they did Inferno for a while, and that fizzled for the most part. I love Inferno. It used a language called Limbo. All of the user mode stuff was written in this language called Limbo, which remains my favorite language, except for the fact that the standard library is like 20 years out of date. Other than that, so then the folks who had written Limbo, most of them went off to Google and wrote Go. Yeah.
So can it do? So it doesn't have a web browser, but it probably can be used as like a web server or a database server or something.
Yeah, my web server runs on it. We don't have database server is sort of an interesting question. I don't believe there's an SQL server for it. There's no theoretical reason why there couldn't be, but nobody's done it. There's been SQL client side stuff, like the client of the Postgres server was ported to it. Yeah.
But the Linux EMU is pretty, I would argue, is pretty good these days, right? And you can run these apps on it?
Yeah, so there was an earlier thing called Linux EMU. The new hotness in one of the forks is called VMX, which uses the Intel virtualization instructions and can provide, you still take a speed hit, but it provides some really nice emulation for, you can run a whole operating system in that thing. And a lot of the people who, I don't use it myself, but a lot of people who use it as their primary operating system rely on that for being able to do so. Yeah. Hardware support is spotty. It used to be better, and then it got a lot worse because it stopped progressing with the rest of the world. And then it's been getting a lot better since, but it's definitely still spotty. And it is unlikely to directly get you a job. There are not a lot of Plan 9 jobs out there. Personally, I can't prove this. I would argue it might make you better at your job. I think it's really, well, here, why you might still want to try it. Because you look like brave, intelligent, charming people. This is the number one reason, I think. It's a great example of how to consistently apply some organizing principle or set of principles to a diverse system. I believe Plan 9 is worth studying, using enough to study for this reason alone, if you are, interested in computer science as a sort of art and science. And it sounds, whatever, but I think it's true. I think this can help you learn how to do this in a way that isn't obvious until you've seen it. And also, personally, I like to use it as much as I can because that fact really makes a difference in how the system feels to use. Plan 9 surprises me in negative ways, way less than any other system I've ever used. That's worth a lot to me. It also, does less in a lot of ways. Like the web browser thing is a big gap, right? Like that's one bullet point on the slide, but that's a big gap. So that's true, but for the things it does them in, I believe, much more consistent and unsurprising ways. You can understand all the parts. Things are smaller, partly because they were willing to go through and say, we don't need, there's new C compilers that Ken Thompson wrote, so, probably a good starting point. And they are not nearly as optimized as GCC or C-Line or LLVM or whatever. They don't aim to be. They produce good code, but not as fast. The compilers themselves are way faster, which, if you're a developer, is maybe a decent trade-off. But they're understandable. They're way, way smaller, comparing them to something like GCC or LLVM. And even more importantly, you can understand how all the parts fit together. This is something that I struggle with when I look at modern Linux systems. I have something in my notes that tells me I'm not supposed to talk about systemd. Sorry.
You violated the notes.
Yeah, I mean, I have a hard time understanding how some of these things are supposed to fit together. And in Plan 9, it is much more understandable, I think. Where are we now? Hardware support isn't that bad. It's still not great. All Raspberry Pis before the 5 and 500 are supported, I'd say, pretty well. 9front, which is one of the forks, distributions, whatever, forks really, is doing a great job with PC hardware support, especially ThinkPads. If you have probably half the ThinkPads out there, you can just assume that everything's going to work on them, which is pretty cool. VMs and VPS support, QEMU, I run it on 2 different commercial VPS providers. I've run it on 1 or 2 others in the past. I know people who've done several others. That works really well. RISC-V is a new and exciting thing on a lot of different levels, and we have pretty good support for that. There are like 1 million RISC-V platforms out there, RISC-V platforms, and we support a small subset of them, but like nobody supports that many of them. There's probably 2 more that have come out while I've been giving this talk. And Kirkwood and Brightstar. No one? Yeah, there's a bunch of obscure MIPS and PowerPC development boards and embedded systems. And if you happen to have an alpha sitting around, that's actually still in the 4th edition source. I don't think anyone's run that in a very long time, and I wouldn't bet too heavy on it working. But it's there. There are three sort of, well, there's really two sort of actively maintained forks or distributions. 9 Legacy is kind of like the old 4th edition, which with a bunch of patches applied. That's what I run. I really like it. The hardware support is not as good. 9 Front is the most active for sure. Nix, not that Nix, not the Unix Nix or Linux Nix. The name, it's another one that like they picked the name in like 2012 or something. I think Nix, the Linux Nix existed but wasn't widespread and they didn't know about it. I really wish they would change that name. I'm not involved in that project. I really wish they would change the name, but they said, we're not going to bother. Fine. It's really cool. It's the most researchy of the distributions because they're saying like, hey, we now have these systems that have like, you know, your desktop system, forget the supercomputer stuff, is going to have like, whatever, 8 cores in it. Let's take a certain core and pin it to an application. So we turn off interrupts. You don't get any interrupts off this core. It just runs the application. And it reduces, it makes it a little faster, but the bigger thing is, especially for supercomputer applications, it means you have a lot less variability in runtimes, which they like. And then there's a bunch of older ones that aren't really maintained anymore that are sometimes interesting for historical reasons, including the original Bell Labs releases, which are now all available under the MIT license. You don't really want to run the 4th edition from the labs unless you're looking for like, you know, archaeology or you know, a historical study. Plan 9 from user space, you can run Acme and RC and our grep and whatever on Unix-like systems. I love this. It's the first thing I install on every Unix box I touch. libthread is the thing that does the CSP style, the Golang's style of interprocess communication. You can get that in all your C code. All the C code I write on Unix, I write using this because it's just a much nicer set of libraries. Doesn't really fix Unix's underlying issues, but like, yeah, Unix gets lots of things right, and it's fine for most things anyway. The Plan 9 Foundation, which I'm involved with, I'm the treasurer and a director. It started in 2021 because we wanted to restart the International Workshop on Plan 9, which is a thing that existed from 7 through 13, I think. And then, like a lot of things in the early 2010s in Plan 9 world, sort of dissipated. We wanted to do that again, so we started the Plan 9 Foundation, and then the pandemic happened, and didn't go away as fast as we wanted it to. And still hasn't really gone away, but it's a little calmer, so whatever. We got Nokia to give us the rights. We now own the copyright, and then in like the same day, we relicensed the whole thing under the MIT license, which is the first time the first two releases were open source, and depending on your definition of open source, it was the first time the third release was open source. The license for the 4th edition was weird. It's technically OSI certified, but nobody liked it for decent reasons. We restarted the International Workshop on Plan 9, which is happening 23, 24, 25, and you should all drive up to University of Victoria in May, where we're having our next one, if you're interested. We're a 501c3. That happened last year, I think. This is where you can get more information. The website is p9f.org is the like official one. 9 Legacy has its own. 9 Front has its own. Plan 9 Port has its own. And then there's an IRC channel and a mailing list. And last year, early this year maybe, I forget, I became the moderator for comp.os.plan9, if you're still using that. Because, it's fun. And that's it. Thank you.
I have a question.
Yeah.
What's the installation process like?
Depends on your platform. So if you're on a Raspberry Pi, you just download the image, burn it to the SD card, and put it on. There are 9 Legacy and 9 Front have separate installers, but you can. There's a variety of options. You can download a CD and do it that way if you want. There are there's different options for which fork you want to look at.
Cool. The other thing I noticed is there's a fair number of YouTube videos about
Yeah.
Plan 9.
Yeah.
It seemed pretty good. I didn't want to,
Yeah.
doing this.
Yeah,
so
yeah.
I didn't watch very many, but I.
Yeah, no, there's some of them
Yeah.
are great. There's a guy whose name I have forgotten that was doing like a series of them, and he did a bunch of really good ones, and then I think he ran out of steam for
Yeah.
like those are work to put together. Yeah, but
I've heard that 9P, like the file of the protocol, shows up in a whole bunch of weird places.
it does.
What's the weirdest stuff that you've seen it used for?
Well, so the most there's derivatives of 9P called 9P. 9P 2000 is the current version of the protocol. There's 9P 2000.L, which is basically has a bunch of extensions that are Linux specific. Were originally Linux specific and now are used by other Unixes, and that's used by VirtIO interfaces in a bunch of QEMU style emulators.
Yeah, I use that to do on my Quemu images. I use that to do the pass through. So I don't have to.
Yeah.
So basically, the host share just mounts like a share on the thing, and
Right. Yeah.
no one knows anything different.
Yeah, exactly. Windows uses it for the Windows services for Linux to talk to the underlying file system for the pass-through in the same way. For a while, if you sort of like tracked what are the new hits showing up for like people asking about Plan 9, for a while it was a bunch of Windows users saying like, what's this Plan 9 process on my computer? Because Microsoft just called it Plan 9, the thing that did the pass-through, which, whatever. The weirdest place? I don't know. I mean, I got to use it one time. I had a week where I was employed, part of a week, where I was employed to reverse engineer, this is my favorite reverse engineering project ever, a Lego model of a clock. They had one, but they didn't have the instructions for making another one, so part of my job was I got a pile of Legos and I had to make another one. And Lego Mindstorm? We ran firmware on the Mindstorm brick that talked 9P and let you set the hands on the clock.
That's awesome.
It was pretty fun. It was a lot of fun.
Like old school yellow brick Mindstorms?
Yeah, the original one.
Man.
Yeah.
One, right?
Yeah. It was a lot of fun.
Whatever happened to ours?
I don't know.
I don't know. It's been used on a handful of things.
Yeah, dredge that up.
There has not been a lot of commercial use of it. There's been a couple of companies have done things with it in that regard. Lucent had a bunch of sort of network-oriented projects. They had a next-generation telephone switch that was using both Plan 9 and Inferno before they blew up. There's one company using it now that does Ethernet-attached storage, and they use Plan 9 on their storage devices. Yeah.
But since we're talking 90s here, the question I have: does it have a Gopher server client?
Yeah, it didn't in the 90s, but now people have rewritten them because everything old is new again. Yeah, there's at least two that I'm aware of. So.
Yeah, because I'm going to go for Gopher server. So.
Yeah.
I assume that Plan 9 is fairly easy to bring up in a virtual machine, say a Proxmox machine.
Yeah.
Like that.
Yeah. I haven't personally tried it in Proxmox, but
Just something to play with.
Yeah.
I run quite a few machines on Proxmox.
Yeah.
So.
Any other questions? All right. Thank you all for listening.
Does it have any 3D acceleration?
No. That was an easy one.
Does it have any 2D acceleration?
Yes. And we use it for exactly. We have 2D acceleration on a small number of graphics cards, and we use it to scroll text windows faster.
Follow-up question.
Yeah.
Does it run on the Amiga?
No, it does not run on the MU.
How about a PDP-11?
No, it never ran on the PDP-11. There are rumors of of the first edition having run on the VAX, but that is not substantiated and is not available now.
Do you have thoughts on the graphical interface design?
Yes.
Good, bad?
I love
terrible?
it. I love it. I focused on Acme for this because
Just as someone who has not done anything, this looks inscrutable.
yeah, I
A
mean,
little bit.
so I keep hitting the mic. So Acme is kind of a lot to take in. Once you sort of internalize the idea that like the whole interface is just text, like this, if I middle click on this word hide, it's gonna, actually I don't know if I have that script installed. No, it didn't work. All right, on this QEMU is not what I normally use. On my normal thing, hide would close the window. I mean, I can click exit and it'll exit the window. But there's nothing special about this being here, right? Like if I just type the word exit here and click on it, it will exit the window because it's just running that command. Once you sort of internalize this idea that like all of the text is just text and also like malleable and executable and whatever, it starts to make a lot more sense. But
So there's nothing special about any of the like teal windows. They're just pre-populated with semantically meaningful text.
Yes, they do. The program, the thread that maintains this window does, like if I start typing in here, it doesn't show up because the thread that's in there backspaces it out basically. It just continually rewrites that part of the tag. The teal windows are called tags. But up here, there's nothing special about it. And like this is the programs that are running within Acme, and I can say, all right, I want to kill sleep. I have killed sleep. I want to kill win. All right, I killed win. And they went away. But there's nothing special about it. Like, I just, type whatever, and that doesn't make that be an application. It's just if I then run win, it's going to stick it up there.
How about if you don't want to use the 3-button mouse? You don't want to use the mouse at all. How easy is it to use?
Not. It really wants you to have a 3-button mouse.
Worse than using Emacs without mouse.
Yeah, it's definitely worse. Yeah, for sure. And like that's an intentional thing. That's a sort of philosophy of the user interface, which not everybody likes, but that's what it gives you. Yeah. Anyway.
So how did you learn Plan 9?
I got an interview at Bell Labs, and I said, like a couple days before the interview, I said, well, I know about all the like Unix and C stuff, but what are they doing now? I should probably know something. And I knew about Bell Labs because they make phone switches, and I knew I wasn't interviewing with that group. And they did all this like C and Unix stuff, and I'm like, all right, what are those people doing now? And that was in 1996. Yeah, and I've been hooked since.
Awesome. Did you get the job?
I did. I got a job with the Inferno business unit when they were still trying to turn that into a like commercial product, and then transferred out of that as they were realizing they didn't. Lucent did not know how to sell software. They wanted like an absurd amount of money for a source code license, and like didn't make any sense. They did bad business decisions. So that group fell apart. I transferred somewhere else, and worked that for a little while longer, and then moved on.
Is that in New Jersey?
Yes. Yep. I was at Murray Hill. I was 4 floors down and 2 stairways over from where this was all written, which was pretty exciting. Thanks.